Alright, in part 2 of this video, since we just got done discussing that example of fractional people, which we would never have, I also wanted to bring your attention to slope. Okay, finding slope given 2 points. So I've been given 2 points, 3, 2, and negative 9, 6. Now I hope that you remember that slope is the rise over the run. I know some of you know that you're having difficulty with spelling, and you think I am too. But that's not the case, because the formula involves the difference of the y values over the difference in the x values. And I'm just trying to emphasize a point to you so that you will remember to put the y's on top. Many people switch those and we get in trouble. I like to actually take the 2 coordinates and write them one over the top of the other one like this. And then I know that I start with the y values. 2 minus 6 divided by 3 minus negative 9. Okay, so we end up with negative 4 over 12. Right? 3 minus negative 9 becomes plus 9. And so we have a negative 1/3 for our slope. Some of you are probably going to ask, is it okay if I do 6 minus 2 and negative 9 minus 3? Yes, you will get the exact same answer. So don't panic. It's fine. As long as you stay consistent, you will be a winner. Point-slope form. Really, you need to understand that point-slope form is the stepping stone to a greater understanding of slope-intercept. In parentheses. Okay? Yes, I know that we can talk about the point-slope form because it has a few things in it, such as a point, or a slope, and a coordinate, right? But really, so for the last example that we were using, find the slope of the line, let's just go ahead and use that to find the equation of the line. Y minus something equals something times x minus something. So there's really 3 things to plug in. If we go back to that original equation, we can pick any one of these points that we want. Say that we want to pick that one right there. We know the slope is negative 1/3, so I might use those 2 points, that point and that slope, and I can write my equation. So 3 was my x value, 2 was my y value, and negative 1/3 was my slope. Now, that is not where I want to leave this. Okay, if I'm trying to write the equation of the line, that may be a good place to start, but I do want to distribute this, giving me negative 1/3 x plus 1, right? Negative 1/3 times negative 3 is plus 1 equals y minus 2. And then lastly, obviously, I want to bring that to the other side by adding. So finally, I'll end up with negative 1/3 x. 1 plus the 2 makes plus 3. So there's the equation of a line that goes through. I know that this is called point-slope form, and you saw me plug in values for x1, y1, and the slope, but don't think that you can just leave it there. You do have to put it in slope-intercept form. Slope and intercept give me just make a whole lot more sense in terms of starting point and change in the value of the line as it goes along. Okay, now the next question. Given 8, negative 1, and m equals negative 1/2, find the line. Well, this is an example. I just did an example similar to that. So this would be a little bit of review. It shouldn't take us too long to do that. We've got our slope of negative 1/2. We've got our x value and our y value. Yes, that turns into a plus. Okay, so we can distribute negative 1/2 x plus 4. And then, of course, you know that I'm going to get rid of this by subtracting it to the other side. So we end up y equals negative 1/2 x. 4 minus 1 makes 3. So there's the equation of that particular line. So what if they give me 2 coordinates only? 2 coordinates only and ask me for the equation of the line. Well, first you want to find the slope, right? So m is equal to, here I'll write the other one underneath, and we'll use our negative 1 minus 5 over 4 minus 1. And negative 1 minus 5 is negative 6. And 4 minus 1 is 3. So we have negative 6 over 3, which happens to be negative 2. So there's our slope. And remember, we can start with point slope, but keep in mind, we can, once we put stuff in, so for instance, slope's going in here, pick one of your coordinates like 1, 5. That'd be a 1 here and a 5 here. Now, for those of you that decided to use 4, negative 1, and you put 4 over here and negative 1 over here, it still is going to work out to the same answer. So don't panic on me. So distribute, and that would give me negative 2x plus 2. And then, of course, I'm going to get rid of that by adding 5 to the other side. And so y equals negative 2x plus 7. So there is my equation for that particular situation. Okay? I know that this is a fairly long video between the first part and the second part, but we'll hopefully I can speed things up. Find the slope of this. This goes back to what we were talking about a little bit before. I hope you can look at this and go, hey, that's a negative 4/3. Okay? And we can talk in class. How in the world did I do that so quickly? If you want to solve it for y to make sure that you are right, then do that. But if you can see what I'm doing with these two numbers, that's helpful. Okay? And I want to glance at what we see in the book here. These three equations are the same line. Here is the graph starting out in point slope form. It's easy to see how you would distribute the negative 3 and add the 2. And that would get you the slope-intercept form, where x and y are on opposite sides. Y is all by itself. And then the standard form is pretty easy to get to because you just move the x term over to the same side as the y term. Okay? And as long as x and y are on the same side, then you have what's called standard form. I also wanted to review with you horizontal and vertical lines. I talked about a little bit earlier how every line, y equals a number, and they call it a constant here, y equals a number, is a horizontal line. Okay, obviously the most famous one, y equals 0, called the x-axis. Vertical line, x equals 0, okay, or x equals a number, constant, x equals 0 being the most famous, the y-axis. Now, I do want to ask you about the slopes because that's kind of important. Okay, so the slope of a horizontal line is 0. I hope you know that. The slope of a horizontal line is 0. And the slope of a vertical line, well, there is no slope. Okay, I want to explain it to you a little bit like this. Cross-country skiing is along flat terrain, usually like this, maybe with slight slopes, but nothing dangerous. So this would be like cross-country skiing right here. And the chance of death is 0. Now, if you were downhill skiing and you came to a cliff and you fell off the cliff, there would be no slope underneath your feet. You would be doing a free fall. There's a definite chance of death with a free fall off a cliff. So, no chance of death, a lot of chance of death. There's a big difference. I always say there's a life and death difference between 0 slope and no slope. So when I ask you for the slope of a vertical line and you tell me 0, I will say no way, and the red pen of death will not like that. Okay? A horizontal line, if you tell me that there's no slope there, then you will also lose points, and I don't want you to do that. Okay? I also wanted to review with you the idea of perpendicular lines and parallel lines. Parallel lines obviously don't intersect ever, and they're also in the same plane. And in so doing, they have the exact same slope. The slope of one line is equal to the slope of the other. Okay? Maybe it would be better if you saw it in color. Here, the perpendicular lines, right here is something that says m1 times m2 equals negative 1. In other words, the slopes of the lines are called negative reciprocals. Or you could say opposite reciprocals. So if you know one slope, you can take its reciprocal and its opposite sign, and you know the other one. Okay? So let's see here. Last example here is find a perpendicular line to this one, y equals 3/4 x plus 2, that goes through the point 6, 1. Well, why do you think they gave me this line? Because I need this slope. So, because they told me that the new line is perpendicular, I know that my new slope, right, the new slope, is going to be the opposite reciprocal of 3/4. And I already know a point that's on that line, so fill it in. -4/3, +6, +1. Of course, we're going to distribute like normal people. -4/3 x plus, let's see, 6 divided by 3 is 2. 2 times 4 is 8. Y, and then we're going to get rid of that and put that on the other side, so we're adding 1 to the other side. Y equals -4/3 x plus 9. Okay, I kind of lied to you because I told you that was the last example, but the only thing I want to do differently is use the last example, but instead of being perpendicular, what if it was parallel? Parallel to y equals 3/4 x plus 2. Still goes through the point 6, 1, but what would that equation look like? Well, instead of having to do something to the old slope, I should be identifying the fact that the parallel line have the same slope. So here's the slope, here's the coordinate, and so I can write my equation, right, and put in my slope and put in my point. 6 goes there, 1 goes there, and so then I distribute 3/4 x minus 6 divided by 4. Ooh, that reduces, right? That reduces to 3 times, I think that's 4.5 actually. I'll change it to a decimal just because I don't feel like messing with it at the moment. Of course, to get rid of this part, we're going to add 1 to the other side. So we have y equals 3/4 x minus, when we add those together, we get 3.5. Okay. See you in class.